Hello, my name is Rob O'Connor from the Department of Computing and Mathematics at WIT. I'm the course leader for the Honours Bachelor of Science degree in Applied Computing, and I'm here today to give you some information on the course, outline what's involved in the area, and hopefully persuade some of you to choose Applied Computing at WIT. As I go through this material, you might have some questions you want to ask. Well, I'd suggest you make a note of those on a piece of paper or whatever you have to hand. Either I or one of my colleagues will be available in the chat booths to answer any queries you might have or to clarify something that isn't clear from this presentation. And questions are good. We like questions. And actually, I'm going to frame this talk around some questions. What and how? What is applied computing? And how is the course put together? There's another question that I'm going to explore first though. Why? So why should you study computing? And by extension, why should you study applied computing at WIT? So maybe you're already very knowledgeable on the area of ICT, that's Information and Communication Technology. Perhaps you've been coding for a few years and you know it's an area you want to work in. But that's great. Skip to the end of the presentation and come over to a chat booth and talk to us about being a full stack developer or which language is better for app development, Kotlin, Swift or React Native. However, that's not most people. Most people don't know a lot about the IT industry other than some of the headline multinational companies, most of whom have a major footprint here in Ireland, whether that's Apple in Cork or Microsoft in Dublin or Red Hat here in Waterford. However, IT is an integral part of pretty much every discipline. Science, engineering, business, finance, medicine, art, culture, you name it. One of the biggest employers of tech graduates in the southeast actually is Glanbia. And the people there work on things like marketing, food product development, agri-tech research, and figuring out new ways for humans to feed ourselves. You only have to think about it for a moment to appreciate just how much technology underpins our daily lives and the extent to which we rely on it. And it's become even more apparent over the past few months. Now, I can blitz you with figures about salaries and how computing graduates earn more money than other graduates, or how many jobs are on offer here in Ireland or internationally. But just take that as a given. You can look it up if you want. Search for Grad Ireland graduate salary and recruitment trend survey. There's loads of data in that. But for me though, there's three main reasons to study computing. Firstly, it's a discipline that crosses every other discipline. You can work in pretty much any area with a computing qualification. Me, personally, I've worked as a web developer for a bank and one of the big four accountancy firms. I've also worked as a programmer for a data science company looking at natural language processing and unstructured search. I recently did some audio work for a virtual reality game, which I found very, very interesting. I've worked in IT for a theatre company and a radio station. I also have a huge interest in music and culture, and I do loads of tech stuff in that area. My point is that computing isn't just about computing. It's about how computer science and technology can be applied to solve problems in other areas, whether that's finance or music or agriculture or medicine or whatever it is that you're interested in. You can be sure that technology is in there somewhere. The second reason I think you should choose computing as a career is that it's constantly changing. I can guarantee you that you won't be doing the same thing for the rest of your life if you choose computing. As tech evolves, you'll have to evolve with it. You'll learn new skills and work in areas that you never even thought of. In the last 5 years, I've learned at least 3 programming languages, and I've worked with technologies that didn't even exist back when I was a student. If you like to try new things, well then this is a great area to be in. Right now, I'm involved in a project about gender and sexual health studies. And if you'd said that to me a few years ago, I wouldn't have believed it. But it's great and it's really interesting and eye-opening. So if you want a job where you do the same thing every day until you retire, well then computing is not for you. But if you fancy a challenge, well then maybe it might be for you. And the third reason I think you should think seriously about studying computing is that it allows you to travel. We have graduates working all over the world, and I don't mean forced emigration or anything like that. If you want to see the world, tech is a great way to do it with some money in your pocket. Personally, I've lived and worked in the UK and Australia, and while working here in Ireland in tech, I've travelled all over the place, mostly European countries, the US a few times. I'm keen to get to some Asian countries in the next while, and there's loads of scope for that once we're out of the global pandemic, of course. My point is that if you're interested in seeing some of the world, a good computing degree can be your passport to travelling all across the globe. There's lots of other reasons why you might want to study applied computing, such as you're into logic puzzles or you want to work for the European Space Agency on guidance systems, or whatever. But for me, the interdisciplinary nature of the applications, the fact that it's constantly changing, and the opportunities for travel are pretty attractive. So now that we've explored the why, let's look at what applied computing is. So it's a 4-year level 8 computer science program. It's called applied because we have a heavy focus on practical elements of computing, such as programming or networking. We also look at the theoretical underpinnings of computing. It's called computer science because it's a branch of science, mostly growing out of mathematics and electrical and electronic engineering. And one of the main differences between this program and other computing degrees is that I think we have the right balance between the fundamentals and practical skills. And that means that when the technology changes, and it will change, you should have a good understanding as to what's going on underneath the hood so that you can change with it. An important point to note is that we assume no prior computing knowledge or experience. We start from position 0. If you've built some websites before or mucked about with some coding, well, that's great, but it's not necessary. We start at the beginning and we all move forward together. Actually, sometimes people who've hacked bits of code together before are the ones who get into trouble because they think they know it all, so they skip class and then they have lots of gaps in their knowledge and they end up in difficulty. That's just a nice way of me saying it's important that you show up for class. So, how is applied computing put together? Well, this is the structure of the course. Now, this image might be too small to see on your screen. Maybe you can't see the detail, but all of this information is on the Applied Computing page on the WIT website. Now, what you can see here is a bunch of modules. They all follow on from each other in 8 semesters over 4 years, 2 semesters a year. These are mostly grouped in thematic areas. We have software and web development here. This runs throughout the entire course. We have computer science and networks and cloud here. Theoretical elements such as mathematics and physics, they're heavily weighted towards the start and then they drop off. We have some data science and databases here. You'll notice that there's some gaps here. It says elective. That's because we have a number of streams that are available on applied computing that a student can choose from. These include cloud and network, computer forensics and security, games development, media development, Internet of Things, and automotive and automation systems. You can test out a specialism in first year and then you choose one of them to study from second year onwards. The benefit of this is that the students make an informed choice come second year. So, for example, a lot of people think that they'd like to do forensics and security because they've seen a movie about hackers, or games development because they love playing FIFA or the Outer Worlds. An area like Internet of Things, well, you might know what that is, or networks and cloud might seem abstract. And the idea is that by the end of first year, you'll have a much better idea as to what all of those things are. And you'll also have some experience in them so that you can make a more informed choice about what best suits you. I don't have time to go into the details of each individual module, but as I said at the start, you can ask those questions in the chat booth afterwards if you'd like. But there's two things I'd like to point out. The first one is that the key skill you'll get from this course is programming. We do a lot of it. You can see there's lots of coding modules here. We focus on traditional enterprise development, web development, app programming. Basically, you'll be what's known as a full stack developer by the time you graduate. That's someone who can code all parts of a distributed system. That's the web front end, the server back end, and everything in between. The second thing to point out is that in semester 6, which is in third year, we have quite a big gap here. This is what we call the flexible semester. Now here, students engage in a semester outside of WIT. For most people, they go on work placement and they take a job with a tech company. Sort of like an internship, except the big difference is that with computing students, they're typically paid whilst on placement. Other options include development work, professional certification, or Erasmus, which is a study abroad program at one of the many European universities that we have relationships with. Up until 2020, this was getting more and more popular each year, but Erasmus has been cancelled this year, obviously, but I'm confident that it'll be back up and running once the pandemic passes. So, what should you do next? Well, you should look stuff up and ask questions. The more information you have, the more informed you'll be and the better choices you'll make. There's a world of material out there about computer science education on the internet. So your search engine is your friend. If you've never programmed before and you want to try something out, have a look at one of the browser-based activities on code.org. Code.org is a computer science education advocacy group promoting more people to take up the discipline because, well, we need more people. There's a bunch of very accessible activities up there right now. They're all browser based, so you don't need any specialist software to run them. In early December, they'll be running a bunch of live coding classes. These are going to be short, around 20 minutes each, so it's not much of an effort to try one of those out. You could also check out tssg.org, which is a research group in WIT which applied computing is strongly linked with. It's not that you'll jump into that straight away, but it's good to know that there's postgraduate study paths right here if you wanted to work towards a master's degree or a doctorate. And finally, I would recommend that you take a listen to our podcast, The Machine, in which we talk about computer science education and break down topics for novices. Recently, we published episodes on how the COVID Tracker app was built by Nearform, which is a software company based in Tramore, County Waterford. Last week, we had an episode on a beginner's guide to cybersecurity. And this week, we have an episode about space research being conducted right here in this part of Ireland. You'll find The Machine on all major podcasting platforms, such as Spotify or Apple Podcasts. So, we're live over in the chat booth right now as part of the virtual open day. So please drop in, say hello and ask questions. If you can't be there or something pops into your head later about applied computing, feel free to email me on rod'connor@wit.ie. I mightn't be able to get back to you straight away, but I will get back to you. So thank you for your time, and hopefully some of you will join us on applied computing next year. Cheers.